Hello, everyone. I'm Hariprasad Holla. I'm a technical marketing engineer for Cisco's Identity Services Engine, ISE. I've been with Cisco for the last 11 years, and for the past 5 years, I've been focusing on identity, access control, segmentation, network behavior analysis. So in short, a lot to do with the network access security. Today, I'm going to be talking about how Cisco ISE and the segmentation solution called TrustSec helps you contain security threats in the network, right? So that's the focus of the session today. It's a 30-minute session, so I do have some slides. I want to talk to you about some of the stuff that we do very uniquely. At the same time, I have a recorded demo that I can play for you if the time permits, right? Now, let's imagine that we are in an airport right now. Okay, close your eyes, think that you're in an airport. And what we see there is we see a bag. And this bag does not have any label on it. There's no tags on it. And we don't have any users around it. Now, this simply means that it's a security risk. It is a risk because we don't know who owns this bag, where is it coming from, where is it going, and what are the contents of the bag, which could be damaging, right? What happens is we see another bag now. But in this case, this bag has a label. And there's a barcode on that label. When we scan, we get to know that, okay, this bag belongs to a username or a passenger named Chuck, and is coming from San Jose. The bag is headed to Barcelona for Cisco Live. That's happening end of this week. And then the contents are being declared safe by the owner, right? We have a lot of comfort with the second bag when compared to the first one. The reason is we know a lot more about the bag just because of that label when compared to the first one, right? So we need, in our networks, to be able to understand, so what is the asset, what's running on it, who owns it, and all of this identity context around it, which can help us reduce the security risk. And later, what do we do with these bags, right? So we don't want to open it right there where we found it. We want to take it to a safe location. We want to first isolate it. We want to segment it. And there, in a safe area, we want to inspect, okay, what's in it, right? And when we inspect, if we find something really damaging, something really, harmful, then we want to discard it. If we find that there's something okay, that's not a problem, then we want to move it to a lost and found area, right? That's what we typically do. So that's what we can apply even in our network as well, right? So identify the assets, and based on that, make decisions on how we want to segment them. And based on that, you can further subject them to inspection. You want to do inspection on the periphery, or you want to go into the details, or you want to go to a deeper inspection. That's what you can do. And in the end, you can decide whether you want to keep that asset to do what it's doing, or you want to discard it. All right, so that's how we want to address the security threat in our networks, right? So how does ISE solve the visibility problem, right? So any of you here who do not know what ISE is? All right, that's a lot easy for me. So just like the barcode on that label, every time we have an endpoint that shows up on a network, we build a barcode. We build a session identifier, okay, to say so what additional context that we can build around this label, all right? So a machine does some sort of authentication. It could be an active authentication or something called a passive authentication that we have supported of late. So we can identify the user on that endpoint. We get some additional device attributes. We can tell what kind of device that is, right? We get some more session attributes. We can tell more information, okay, in terms of where it is coming from, the timestamp, and how that particular endpoint is connecting to our network. And then if I have the specific agents like AnyConnect, I can tell the applications that are running on the endpoint. I can also integrate with device managers. I can get the compliance status of the endpoint. We can integrate with the vulnerability scanners to get the vulnerability status of the endpoint. Like, what is the CVSS level? Is it like the lower, somewhere within 3 or within 5, or it's higher, like somewhere close to 10? If we integrated with Cisco AMP or Cisco Cognitive Threat Analytics, then we can get to the threat level of the endpoint. So we can build a lot of context around that label that we can get regarding the asset on the network. All right? So it's all the additional information that we can know about that endpoint. So more that we know, we can reduce the risk level. Okay? So just like the bag that we know with the label. So this is how it looks on an ISE page. If you log into ISE, you would see the data or details like this. The user, device, location, all the additional attributes in terms of the applications and all the other threats and vulnerability data that we care about. All right? So from here, what I can do is I can take all of this context and I can summarize it into a security group tag or a security group, SGT. All right? So that's what I can do. So I can say, like, I can build a policy which says a user who belongs to an employee group, who owns a specific type of asset, who connects from a specific location, whose posture status is compliant, will be getting this particular group. Okay? Now, what does that group really mean to me? It means to me that I can do an effective segmentation now. Okay? I can have policies like what Larissa was talking about, where I can have the source groups and the destination groups, and we can define policies saying what source can access what destinations. And these policies could be south to north, like the user trying to access something in the data center, okay? Or it could be from user to user communication as well, like the policy out here, right? So there's an employee and then an employee group. Between the employees, what can they communicate? What are the applications they can communicate with each other? Okay, this is quite important. This kind of an access control on an east-to-west flow in the network access is quite important. And we can do this on a catalyst access switch. We can do it on a wireless access point, right? So this kind of east-west segmentation, right? So where is this helpful? It's helpful in addressing issues like this. Okay, when you look at the outbreak, the Wannacry outbreak that happened last year, when we go through it, what we understand is the machine that is infected with Wannacry, okay, tries to discover the other host in the same segment that has the eternal blue vulnerability in it. And once it understands that there's an endpoint that can be breached, so it kind of passes on that particular infection to those endpoints. So it basically tries to move laterally from host to host in your network access. If I have a policy like this, okay, I can contain them. In fact, I have a demo that shows how exactly I can do this. Okay, exactly I can contain Wannacry with the help of TrustSec segmentation. But this is something that looks so simple, and it's really very effective because I just specify what are my source and destination tags, and between the source and destination, what are the applications that I want to permit or deny, right? So in this example, I choose to deny some of those applications that could potentially be harmful.
Now, pardon my extreme ignorance of what this is. I'm just not familiar with it. Where does it apply that?
Where is this policy set?
Yeah, where is that policy pushed to?
Yeah.
And how is it pushed?
This policy that we're talking about, this can sit anywhere in your network. All right. So if I talk about a user, and the user is trying to access something in the data center,
okay,
on the path, the user can send its traffic through an access switch or an access point, then up to the distribution switches, routers, WAN, and further to the data center. All through the journey, I can have different devices that can take part of these policies, and they can enforce it.
Now,
okay?
Here's my $1 million question.
Yeah.
What if part of my infrastructure is not Cisco?
It's not a problem.
Not a problem. It'll
Not a problem.
Gear?
Yeah. So even if I have third-party gear, and again, I can talk about it for hours. It depends where your third-party gear is. Is it at your access, or is it in an intermediate, or as it your data center? Where is it, right? Depending on where is it, we may have to tweak this a little bit, okay? Because this example, for example, if I talk about the user-to-user segmentation here, this policy would sit on my access switch.
Okay.
This would sit on an access point of a Cisco access point, a Cisco switch, because we don't have a third party supporting it.
Okay.
However, the solution is quite open. We do have third-party firewalls and third party who are adopting this, right? Who have already implemented it. the customers who have taken it, who have deployed it. But in terms of network, we are the only ones that can do this, at least on the network access point of view, right?
Thank you.
So what this does essentially is, traditionally, if you think of segmentation, we think of VLANs, right? Or we think of ACLs, in order to do all the segmentation. So what we do here is we take a 16-bit, security group tag, and using the tag, we do the segmentation. We say, okay, what are my source assets and what are my destination assets and what the source and destination can talk. And any given point of time, the tags can be mapped to a specific IP address or set of IP addresses. Okay, so that's what we can do. Now, talking about vulnerabilities and exploiting the vulnerabilities, how to contain them. So in this particular example, I may be having a host that is not even patched, okay, for the Eternal Blue, but I can still protect it with this kind of a policy, right? But with ISE, you would be knowing that we can enforce posture compliancy, where I can mandate that if you're not fixed yourself to those latest patches that I care about, I wouldn't even give you network access. Okay, I wouldn't even give you the right security group assignment so that you can have the level of access that you need. Okay, so we can go to that detail.
Now, for the posturing to work properly, though, do you have to drop an agent on the endpoint?
Yes, we need to drop an agent on the endpoint because it's the scalable way of doing this. Okay, for thousands of endpoints if we were to do it. And as part of agents, we do have multiple options there. We do have a permanent or a persistent, and we have a temporal agent, which is self-dissolvable agent, what we call. And the other option is we have a stealth agent, which is an agent that sits on an endpoint but doesn't show up. The user doesn't see the agent. Okay, it sits on the endpoint. It's as if there's no agent running on it. Okay, but we have an agent which is kind of helping us monitor and kind of enforce the policies that we care about.
In environments, Microsoft environments, would you be able to hook into SCCM or any of the patch management systems?
Yeah, we can certainly do that. That's what I was trying to say here. So we can integrate with device managers, SCCM, mobile device managers, and we can get the compliance status from there, and we can enforce the policies. The patch level,
You don't need to have an agent in that kind of environment.
We don't need agent if I'm using a mobile device manager or a device manager integration.
Okay, thanks.
Yeah. All right, so we now know that ISE integrates with a lot of different services like mobile device managers or device managers, could be the directory services, vulnerability scanners, and what we can do is across the wired, wireless, and VPN connections. So those are the three main avenues how someone can get onto the network. We can assess the endpoint, and we can build the context. I just explained about how we build this context, right? And we also do is we can summarize this context into a security group. Okay, so the next thing that we do. With this, what we essentially get is we get greater visibility about the asset, everything about the asset, the device in itself, who owns it, what's in it. Okay, is it good or bad? We get all this data, and based on that, we come to a decision. We come to a conclusion, so what we need to do with this. Okay, what should be the level of access? What we can also do is we can share this context to an ecosystem partner or ecosystem partners so that they can reuse the context for something better. Like Larissa was talking about firewalls. So the firewalls, if I were to construct a policy based on the security groups, I can take the integration from ISE. I can get all the security groups and its associated endpoints, data from ISE, and I can build a policy on my firewall. Okay? If I were to do some inspection, some real-time inspection with an IPS or a platform like StealthWatch, I can basically tie in back the context to all of those things that we have built to whatever the inspection that I'm doing. If I'm looking at an IP address that is behaving in a way it should not be behaving, so I can go back and check what exactly that IP address mean to me. Okay? Now, when I say that I can exchange context, I mentioned some options here. I said syslog, REST API, pxgrid. All right, so syslog is there from the day one. APIs, you can pull in the required context out of ISE that you care about. But pxgrid is something that we believe is the better way to share or exchange context. Because if the APIs, this is how the integrations look like. It's a one-to-one integration. It's a platform-specific integrations. And it's not very effective. Okay? And it's not very scalable when you look at in large deployments. Whereas the pxgrid takes something like this approach. All right, so where we have the different services, okay, that they can have one single connection to the grid, and they can publish and subscribe whatever they care about, and thereby we can scale the integrations and we can move the data very effectively. Okay. So more about PX Grid, because it's very foundational to how we do threat containment with ISE-based solution. It's an open standard solution. We do have a lot of vendors that are adopting this one. It's an IETF. We haven't got an RFC yet, but it's in a draft state right now. We do have different roles in PX Grid. We do have a grid controller, which authorizes who can connect to the grid and who cannot. And then we do have these roles like publishers and subscribers. So it's like a group chat. So you can subscribe to a specific group and you can take the data that you care about. If you're a publisher, you can put some specific topics to the grid. All right? So when I talk about topics, there are some interesting topics that I've called out here. Topics like session directory, which talks about all the session that ISE builds, all the who, what, when, where, all the stuff that we build. We can share it with the help of the session directory topic. All the TrustSec related data can be shared from ISE to an ecosystem partner with the help of the TrustSec metadata. And these two, the endpoint protection service and the adaptive network control, are purely meant for threat containment. Okay, we use this for threat containment activities.
Just a quick one. Can you clarify what's the difference between firepower and NG-IPS?
So this could be an ASA with firepower. This could be NG-IPS. All right.
And so that the PX Grid controller, is that an ISE node?
Yes.
Is that a policy services node that lives in your ISE environment?
Exactly.
And then your publishers are any of these other devices?
This could be any of the other devices.
Are those also subscribers?
They could be subscribers, they could be publishers. Like, most of them typically take the context from ISE. Like we do have this industrial network director, which is a Cisco's controller for the industrial network devices. Like we have the industrial switches and we have the industrial wireless networking devices. So the IND basically controls all of them. So we can integrate with that and we can get all the device context from IND, right? For example, we can publish the data for a Cisco WSA so that I can go and construct policies on the WSA.
And so is that PX Grid controller, is that just something you connect all these nodes to, or is there configuration or policy around that controller where you define which publishers and subscribers can talk to one another, or is it just sort of a central, you point the other devices at this and it takes care of
so
work?
We need to do the integration. That needs to be done, okay, in each of these. We need to approve that in ISE. And when we do the approval, you can also further go and say what topics they are authorized to publish or subscribe. Okay, you can go to that authorization level as well. So as you said, as you rightly asked, and what we know now is ISE is the only PX Grid controller today. But this controller could be sitting elsewhere as well in the future. Okay, but ISE in itself, as you said, ISE, one of the ISE PSN is the PX Grid controller, and I can have the ISE monitoring, troubleshooting, and the admin nodes doing the publishing and subscribing to that particular grid. Okay, so we can do that. So talking about some of the topics, session directory, here is an example like how the format looks like. Like you can see, like there's a user context, there's a device context, there's a posture status, and all of this information that can be shared to the ecosystem partners. All right, and in the similar fashion, let's talk about the adaptive network control topic. Okay, so this is very specific or very much in line into how we do the threat containment activities. Now I have a host in my network that has a specific IP, the same endpoint, and it has got an employee security group tag based on the initial authorization from ISE. So what happens now is this machine is getting infected with a malware or with some anomalous activity, and I have my security systems in my network. It could be StealthWatch, could be my Firepower, could be some third-party systems. It could be the other ecosystem partners that we have integrated with. And they kind of see a problem, and they kind of can alert us over the adaptive network control topic. And they can say that this is the IP address that I want you to take action for. And what ISE can do is I can have a policy within ISE which states like, what should I do in this kind of a situation? I can have a policy which says, if I see that I get a request for a quarantine from my ecosystem partner, then I'm going to do a change of authorization, and I'm going to change the security group from what was the initial employees now to quarantine security group tag. right? So this is what we do. So what happens when I change the tag? I can have different policies for these tags, okay, across my network. I can have different quality of service treatment. I can have different access control policies to it. And what's interesting is the IP address hasn't changed. The end user doesn't know something is going on. The malware, the threat actor doesn't know that someone is inspecting, someone is knowing that there's a detection, because we haven't changed the VLAN, we haven't changed the IP address. Okay, I haven't even pasted an ACL yet. I've just changed the tag. And changing the tag could mean I can further use this tag in my network to go deeper on that particular traffic. Okay? So in terms of policy, this is how the policy looks like, for example. So I can say if I receive an ANC quarantine, adaptive network control quarantine, then I'm going to change the security group to the quarantine security group tag. And here is what I was talking about. So if I have an endpoint that is infected with the malware and I change the tag, then in my network, I can do a policy-based routing so that I can send it further somewhere for deeper inspection. Thereby, I can use all my inspection system in much more efficient manner. I don't need to inspect every single traffic. I can have a solution like, let's say, Stealth Watch or something on the endpoint that gives me a high-level alert that this endpoint is behaving suspiciously. So once I change the authorization, I can send the traffic through a different path so that I can inspect what's really going on in that particular endpoint. So it kind of scales the solution very well and kind of helps me utilize my resources in a much more sensible manner. Okay? Any questions?
When that happens, when the user gets quarantined, can you redirect DNS to kind of throw a captive portal up to an end user and say, hey, you've been quarantined?
Yeah.
Call IT.
So what I can do here is I can give an URL redirect authorization, and that URL redirect, the web page could be hosted in ISE, it could be hosted in third-party web server. Basically, you get a notification, and you can act on it. You can, if you want to self-remediate, if it's something that can be done from the endpoint standpoint, right, we can self-remediate it. Yeah. And talking about remediation, we can do something more from ISE. All right. So if I know a specific process that is impacting, if I know a specific application that is bad, I can initiate the action right from ISE, okay, to go and uninstall or kill that particular application. Because if we have the agent on the endpoint that we can talk to, we can administrate, then we can do this. We can go and kill or uninstall.
Can you just a little bit elaborate? Is this using the M for endpoints?
No, this is using AnyConnect. This is using AnyConnect. It's using the posture module on the AnyConnect, with the help of which I get all the app metadata. Once I get all the application and all the processes that are running right now, so I can use this from ISE. This is a snippet from ISE where I'm showing how you can select the application. You can say, I want to uninstall this. I don't want it on your system. Or I want to kill this particular application. Or I can define a posture policy on that and say, none of my endpoints in the network should have this application. Okay, I can do that. Sejang, do we still have time? Okay, a couple of more minutes. Okay, so I won't be able to do the demo then. Yeah. I can do the demo? All right. So, I have a recorded demo. I'll just, it's just something that I can play quickly. It's just to show the way how we can solve the lateral movement, how we can contain the lateral movement in a Wannacry kind of an outbreak. All right, so here is an example. I have an ISE authorization policy. This is a quite simple policy. Haven't really used a lot of the conditions here. The condition is pretty simple. I look for if the user is part of a specific Active Directory group, and then we assign a specific security group tag. So I say, okay, so if you're in part of employee Active Directory group, and I'm going to give you an employee access. So there's a machine that's going to come in, and then we see it like the employee has just logged in, and we have given the employee the initial authorization, which is now we're giving a permit access, and the employee has the employee security group tag. All right. So further, what happens is this machine is the user has logged in and just logged the screen, and you can see the screensaver on the machine on the user system. So I go to another machine on the same segment. So this is the attacker system. All right. So what happens here is I'm running the Metasploit. So what I do here is I go and I scan the network, okay, to see if there are any machines with the set of vulnerabilities out there, and I see that there's a machine there that's the employee's workstation that is open at a specific TCP port, which can be of our interest. And then we go and the Metasploit kind of tells me that I can go and attack that endpoint, and I use the eternal blue exploit. Okay, so I just go there, I just go the eternal blue exploit, and I try to get hold of the system. So it's basically not patched, so it can be subject to Wannacry kind of an malware. So I go there, and then what I do is I get to the system, I see a lot of details about the system. I can go and further change things on the system, like I can go and I can do a screen grab. Okay, now you can see I do have two systems here. This is the employee system, and this is the attacker system. I can see exactly what screen is going on my employee's workstation. I can also go and change the employee's desktop background. So I'm putting the Wannacry background so that the user next time logs in, he sees that, okay, there's a Wannacry message. System is encrypted. I haven't encrypted anything, but it's just that I use the same vulnerability to get onto that system, that vulnerable system. But what we do now is we go back to ISE, and then I have this security group access control list, so that I was talking about in my session. And we do have a policy to block a specific port, like 445. And what I do here is I go to the policy metrics, and as you can see, between my employees and the employee group, initially there was a permit IP. Okay, anything can be, they can talk, they can exchange anything. But what I do now is I go and say that I want to change the policy to more restrictive. I want to put the policy, and now we have this policy here. And what I do next is I click on the deploy button. There's a deploy button out here. I click on it, and the moment I do it, the policy goes and sits into my network. Now this policy is being pushed to my network devices. It's not pushed to basically the endpoint's access session, okay? So I push the policy right now. Now what happens is if I go back to this attacker system, you see the Metasploit session has been expired, okay? So I'm no more connected to that endpoint, right? So that's just an example like how even if the system is not patched, with the help of a access control policy between the users, how I can restrict that particular malware from spreading.
So it looked like it was just an ACL to deny SMB traffic.
Yeah.
But if you're using SMB2 or something on a patch system, you're effectively blocking that as well, right?
Yeah. So it is an ACL, but it's an ACL that is IP agnostic. Like in the sense, like I don't really care about who's sitting there. So, but I can look at a specific roles between the source and destination, and then I can apply the policy. Right.
I guess it's not identifying, hey, this is a Wannacry attempt.
Yeah.
We're just blocking SMB all out, which yes, it'll block Wannacry, but yes, it will also block your SMB legitimate traffic as well.
Right.
Yeah.
Right. So that's what the access control option that we have in the network access. So that's what we can do.
Okay.
But if I look at something that I can do on a northbound side of it, I can really go deeper with my firewall policies using the same identity context. Like I can use the same source group, like employee group, and if it's trying to access something else, then I can inspect. But I won't be able to do it at my network access. This is the best we could do at the network access, and that's what we do with the TrustSec segmentation solution.
Makes sense?
Yeah. All right, so I'm already out of my time, but just want to summarize what we just discussed, right? So we want greater visibility so that we can reduce the risk. It's like having the bag with the label so that at least we know this is okay, this is not that bad, all right? And then if we know more and more about the asset, then we can segment it effectively. Okay, so good versus bad, okay, employee versus contractor, whatever that I want to do, I can implement effective segmentation. And TrustSec lets you do segmentation without the need for changing any of your network topology, right? And we need better way to integrate systems, right? So in order to integrate the different security systems so that they can talk and we can make real sense out of it, we need better way to communicate, and PX Grid enables those communications. With all of these, what we essentially get is we can do rapid threat containment. We can really reduce the time to detection and containment with all the solutions in place. Right? So with that, I end my start session. Can
Can I ask you one question before you
Yeah.
go on, actually? And this may be just my ignorance there, but when we're talking about TrustSec providing segmentation and using these tags to do routing, is that tag just an abstraction that's hiding some like tuple that are behind the scenes, or you're not actually tagging traffic, are you? Or what does that tag
You can do
mean
both.
exactly?
What I can do is I can tag the traffic, like your .1Q tag. All right, so every hop or in all through the journey of the traffic, I can have a tag contained. I can architect my network in that way that I can carry the tag everywhere. That's the most scalable way of doing TrustSec, because just like your IP address or your VLAN tag, the tag is there in the payload itself. So it's easy to inspect, it's easy to know, it's easy to do all the access control. If for some reason I can't do, like he mentioned, like, what if I have a third-party network, or if I have my own Cisco network that's not capable of doing this tagging, then we do have this, protocol for exchanging the IP address to security group tag binding, which is very similar to what we do your BGP or any of the routing protocols. So I can run a TCP session between a speaker and a listener. The speaker tells the listener what is the IP address to security group tag binding. And on the listener, I can do a policy enforcement, which could be based on tags. So whenever it receives an IP traffic, pure IP traffic, no tag in it, it looks into the binding table and says, okay, this source IP address, what tag does it map to? Right? If it maps to a tag, then we enforce that policy. If it doesn't map to a tag, then there is a default policy for unknown tags, and we enforce that policy. We can do it that way. Right? Yeah.
I have a question. This is out for quite some time, yeah?
Yeah.
This solution, this whole bundle.
Yeah.
It started really as a pure campus play. That was the #1 use case, yeah? Will you involve it also to support data center products?
Oh, yeah.
So that you can leverage kind of the same TrustSec story to Nexus switches and things like that?
Yeah. So a couple of things here. One is, when we started with TrustSec, Nexus 7K was one of the platforms that supported from day one, right? So if, like in data center, if I have a Nexus 9K versus things that are not Nexus 9K, if it is anything other than Nexus 9K, then I can do TrustSec natively. Like, tagging is supported in all of those platforms, 5Ks, 3Ks, 7Ks. If I have Nexus 9Ks, we do have our own policy model there called ACI. Okay, and TrustSec and ACI can work together. Okay, so we have this notion of EPGs, endpoint groups, in ACI, which is a 16-bit tag, and we have the security group tags, which is 16-bit. So we do have the translations that we can do in the network from TrustSec security group tag to ACI endpoint groups, and we can build policies end-to-end. Okay, we can do that.
So you see this also as a valid use case for that, yeah?
There's a lot of, this is one of the major use cases, the data center use case.
Okay.
Okay, so that you can automate, or you can simplify your firewall policies, you can do access control at your data center. Not just that, we are moving this thing to the cloud as well. All right, so if I have a workload in, let's say, Amazon Web Services, I should be able to construct a policy based on the security group. I have the source groups from my network, and even the Amazon Web Services, they may have their own security groups. We can translate that back to a security group tag, and we can write policies as well. So it's not about data center. It's about campus, data center, and as well as the cloud.
Just one additional question. Sorry,
Sure.
we are running out of
Sure,
time.
sure.
What would be your best approach? It's wonderful if you have a client that runs on the endpoint, wonderful, yeah?
Yeah.
But sometimes you cannot do it, yeah?
Yeah.
It's a
Sure,
printer
sure.
or something
Yeah.
where you cannot have all this, let's say, endpoint.
Yeah, so the
intelligence.
majority of the services that we deliver, we do not need an agent. So if you want deeper data about the endpoint, we'll need agent. But we do have options where we can integrate with the other device managers to get those additional context. That's one of the options. And as a matter of fact, we kind of making some small steps in going agentless. Okay, but agentless comes with its own baggage, right? So it's not very scalable. And we have seen in some cases where we prototyped it. The agents give us more accurate data versus an agentless, because it's always you have to log in and get the data that you care about, right? So there's a difference between that, right? We need some agents. If it's a native agent that can be sending data to some other device manager and we can pull the data from there, we already do those kind of integrations, all right? And agentless, we're doing some small, steps. We're kind of coming up with some solutions around agentless options. Yeah.
Okay.
So we understand the problem. We're trying to address it. Yeah.